Hi, in this video, we'll learn how to design and 3D print splints completely in-house in just a matter of minutes and at a fraction of a cost to not only increase our turnaround time for our patients, but also to reduce the fabrication cost by 10 times. So let's get started. First step is to create the order form, select splint and then select the material. If you're going to 3D print, it's not going to matter which material indication you select here. Once done, hit next and start scanning the mandible. Following the scan strategy for the lower arch, starting from occlusal till we reach the bicuspids, then we start the buccal followed by lingual moving forwards in the same fashion till we reach the bicuspids on the other side, following the occlusal surface till the terminal molar. This is then followed by the lingual surface. One clinical tip here, always have the scanner covering 50% occlusal surface and 50% of the lingual and complete the arch to have maximum accuracy and then rolling over and completing the buccal the exact same way. It's always advisable to trim the unnecessary data so that it doesn't interfere with the future alignment of scans. Once done with the lower arch, we repeat the same steps and finish scanning the upper, followed by recording the bite, even though we might not need it in this case, but it's always better to scan the full palette when you're scanning for splints. We can create a new case while creating the splint by clicking on the digital impression on which we intend to design the splint and then selecting Splint Studio from the option available at the bottom. As soon as you do that, it would ask you whether you want to design the splint on the upper or the lower arch. In this case, we intend to create a splint for the maxilla, so that's what we select. Once done, the first step is setting up the occlusal plane, which we do by marking 3 points, one on 1,6, another one between 1,1 and 1,2, and the last one on 2,6, and you hit next. At this stage, we enter the bite configuration window where we have the virtual articulator activated. At this stage, we can decide how much separation we want to have between the maxilla and the mandible, which would eventually dictate the thickness of the future splint. In this window, we can decide which all movements we would like to simulate over the articulator to minimize the requirements to do extensive equilibration post delivery of the splint. This is the place where we create a perfect. Once done, we hit next and we enter the blocking out window. This is the place where we create a perfect path of insertion for the future splint for easy insertion and removal. Under insertion direction, we see two icons, one from view and second one auto. As a rule, I always prefer to select the path of insertion manually rather than using the auto feature. So you set the model in such a way, imagining that the direction that you are viewing the model would be the path of insertion or removal, and you hit from view, which will then show you everything that would then act as an undercut by showing a blocked out model, and the future designing of the splint will now be continued on this model. Once we hit next, it enters the wax trimming window, which normally I have not felt the need to use unless you have some surface irregularities that you would want to correct in the model. So we go ahead and hit next again. Once we hit next, we enter the main window where we would be designing the outline of our splint. We start with left clicking dot by dot on the boundary of the splint that we want to create. Now this is as per the clinician's choice whether they want to have like a straight boundary of their splint or they would want to follow the scallop. The marking technique can be done in one of the two ways. One is by clicking point by point and going ahead in the marking, and the second way is keeping the left mouse click pressed and then drawing and moving ahead. In my personal opinion, I find it actually more difficult than drawing dot by dot. So creating a margin dot by dot is way more easier honestly speaking, than using a mouse to draw a particular curve or a particular surface. So we do that for the entire palatal following onto the buckle. So in the buckle, you can see that the part of the model that is blocked out, you need not extend your margin into that area because there is no point. It's going to remain open. So you can have it almost at the middle third or just at the level of the blocking out of or the virtual blocking out that is happening over there. So as I said, you can directly take the left mouse click and directly draw a straight line, or you can go click by click onto the entire surface, giving you more control. So it's not that you have drawn and it's like a one-time thing. You can always finish the entire boundary or entire outline and then go ahead and fine tune whichever areas that you would wish to. Like for example, I want to get this premolar slightly down, so I'm going to just go ahead and click slightly below that, and it would automatically modify the margin over there. And the same way we can do it everywhere. You verify everywhere and then we hit next. As you can see, we have a rough outline of the splint ready. Now the Splint Studio is bundled with a lot of features. So I'll try and show a few things that you can do with it, and then it's up to you to design and customize it as per the requirement of your case. The first option that you can see over here is called raise to antagonist cusp tips. So what you do is you go ahead and mark the parts of the scan that you would want the software to raise it to the level of the antagonist cusp. So if you missed a part, you can always go and extend that much part and let the software finish its calculations. Once the software has finished its calculations, you can see that it has raised the plane to match the lower cusp tips. Now the second option is raise to the antagonist plane. So like before, you go ahead and mark the areas on the scan that you would want it to raise as per the antagonist plane. So like before, if you have missed certain areas, you can always go ahead and fill it up. The moment you select the desired area and click on the option, it will immediately bring up the entire occlusal plane. And if there are any changes that you would like to bring about at this stage, you can do that. If not, you can go ahead and hit next. Now we enter the most crucial part of our designing step, which is adapting the design as per the occlusion. So the software allows you to simulate all the movements like protrusive, lateral excursives, everything, and then you can adapt your entire splint as per the mean values that are set on the virtual articulator. So what you're seeing with that play button is all the movements that you had selected, like protrusive, right and left, excursive. All the movements gets simulated the moment you press that. Each and every movement is color coded. So then based on that, whatever markings that you see, you can decide whether you want to leave those or you want to remove those, and you can go ahead and use the remove tool and remove all the places that you do not desire the lower teeth to make contact with. So you can have a nice canine guidance or a sort of idealistic occlusion or a removable idealistic occlusion at the end of your treatment step or at the end of your designing, which is the primary aim of creating the splints in the first place in most of the cases. Now this is where it's up to the clinician to customize this step and use it to their advantage as much as they can. So you can see here that by selecting the option over there, we now have the protrusives in black and the excursives in blue, where it's showing that nicely you have eliminated all the posterior contacts when there is an excursive movement, and you have two protrusive marks between the central and the lateral. So if you wish to do any more modifications, you can go ahead. If not, what I am doing over here is I am smoothing the entire design because I have made some changes there. I would love to smoothen the entire buccal surface also slightly so that it merges well and it's very comfortable for the patient to wear it. Once this is done, at this step, you can try and spend as much time as you wish to. Once you get the hang of it and once you know exactly what you want to create, you can finish this quite easily and quickly and then move to the next step, where you can either decide to put an ID tag. So most of the times it's not necessary to do that, but at some point of time, if you feel that you're giving it to two people in the house and they might be confused whose splint is which, then you can put a small ID tag which you can engrave or emboss as per your wish. I would always suggest you to engrave it because then it doesn't feel like a bump outside the splint and it's very comfortable for the patient. Also, it adds on a little value of customization where some patients are very happy to see their name engraved onto their splint. So it's absolutely your choice whether to do this step or no. But if you're going ahead and do it in a small way where it's not going to really hinder the patient's day-to-day functioning and it's very easy to clean. So once done, you hit next and you have your splint ready, which you can save it to wherever you desire on your computer. The final step is 3D printing the splint that we have created. Chi2Box is the software that we would be using to slice our STL file. The first step is to drag drop the STL file into the slicing software. Once it's on the build plate, as you see on the screen, you go and you select the printer. Since we have multiple printers in our office, we select what printer and what resin we are going to use. Resin profiles are pre-calibrated by us, so we won't be making any changes. So now we go ahead and we set it. It is ideal to print the splint with the anterior part facing down and the posterior part at about 40-45 degrees. This creates a self-supporting structure. Of course, we will be adding extra supports to it, but this is found to have the maximum accuracy and least amount of finishing as compared to printing it horizontal, which would have also very good accuracy but would require a lot of finishing, and as compared to a completely vertical, which would have the least amount of accuracy and would require the least amount of finishing also. So once this is done, you can see on your right how much of resin it's going to use, how long it's going to take to print, and the final step is to save it in a USB stick and then stick it into your 3D printer and select the printing file and go ahead and print it. I hope you found this video helpful. If you did, please do share it with someone who would find it helpful and leave a like. It would really mean a lot to us. Subscribe to our channel for more such informative videos in future. Signing off, Dr. Mayank Doshi. See you in the next one. Bye-bye.